Right. Today we are going to see the proof of this one. What is this? This is one of the standard form of limit. What are standard forms? See, standard forms are nothing but just like a formula. But how this formula have come, we are going to discuss here. So exactly what I am going to say is, I am going to explain how sin x by x value is equals to 1. So I am going to explain the proof of this. Okay. So we have the standard limits. Out of that standard limit, one of the standard limit we are going to discuss about. So first, before seeing of this, let us try to substitute and see what is going to happen if I substitute x value 0 here. See, substitution is one of the basic method to find the limit of a function. So what is this sin x by x? Sin x by x is a function. Okay. So how to find the limit of a function? By substitution. If the substitution doesn't work, or if the substitution gives the indeterminate form, then we'll see the factorization, rationalization, okay, and we'll see the other methods. Then we'll use the standard limits. Okay. So first, to find the limit of this one, I wanted to try with the substitution method. Okay. So let's try to substitute x value 0 here. If I substitute x value 0, it is going to become sin 0 by 0. So what is the value of sin 0? 0 by 0. What is 0 by 0? It's an indeterminate form. Indeterminate means cannot be determined. We cannot determine, therefore we are calling this is indeterminate. 0 by 0 is indeterminate. So this is the reason why substitution method is something which is not going to help us. But we need to find the limit of this one. Okay, so this is what we are going to see it here. Right. Right. So to prove this, but still we are saying the value is 1. Okay. So how this value is 1, we are going to see it. So to prove this, we are going to use, okay, a few things. You must have the idea about these things. One is sandwich theorem. Okay. And second one is you must have the idea about sector area formula. And next, basic idea about sector area. See, that is that is a very simple thing, you can find it. So but the most important thing is sandwich theorem. We are going to take the help of sandwich theorem to prove it. So what is sandwich theorem? See, sandwich theorem is about this one. For example, there is a function. Let's assume that function is f, and there is another function that is g, and we have one more function called h. So there are three functions f, g and h. Okay. Generally we'll write the functions as fx, f of x, g of x and h of x. So these are the three functions. Okay. And these functions are in this way. They can be equal to f of x is equal to g of x is equal to h of x, or for example it may be like this: f of x is less than g of x, g of x is less than h of x. Okay, if the functions are in this way, if three functions are in this way, and if the limit of f of x and limit of h of x is same, if the limit of f of x and limit of h of x is same means, for example, let us assume the limit of f of x is L and limit of h of x is L. That means these two limits are same, right? F of x and h of x limits are same, right? Once these two limits are same, then g of x limit is also going to be L. So this is the sandwich theorem. Okay, let me explain in the verbal way. If f of x and g of x and h of x are three functions in such a way that f of x is less than or equals to g of x is less than or equals to h of x, then f of x limit and h of x limit is same. If f of x limit and h of x limit is same, then g of x limit is also L. If f of x and h of x limit is L, then g of x limit is also L. Okay, so that is the sandwich theorem. Once again I am repeating, if f of x, g of x and h of x are in such a way that f of x is less than or equals to g of x is less than or equals to h of x, then limit f of x and h of x is L, then limit g of x is also L. That is a sandwich theorem. Okay, so based on that we are going to understand. We are going to take the we are going to understand this. Okay, so let it be this one. So, and this is one thing. Next, to prove this, okay, I am going to take a unit circle. Okay, what do you mean by unit circle? Unit means it can be any unit. I mean, it can be 1 centimeter, 1 meter, 1 feet, 1 yard, or it can be. It must be one. Okay, the magnitude must be one. So I am going to take a circle. Okay, so let's assume this is one circle. Circle of radius 1. What is this circle? This circle whose radius is 1. And the center of this circle is, assume it is O, and OA is the radius of a circle. Now what is the value of OA? 1 unit. Now what I am going to do is, okay, I am going to take something like this. I am going to draw, take another point. I am going to take one more point on a circle which is something called B. Okay, now OA and OB are the radii of a circle. Radii of a circle and radius is 1. Now imagine the angle between these two radii is something called x radians. It's not angle, it's not degrees. Okay, the angle between OA and OB is in radians, x radians. Okay, right. Now what I am going to do is, okay, I am going to draw a perpendicular. I am going to draw a perpendicular from B to OA. Okay, so what is this? This is a perpendicular. So BC is a perpendicular which is drawn on OA. Okay, right. Next, once again, what I am going to do is, I am going to extend this OB, something like this. And next, from A, okay, I am going to draw a perpendicular. Okay, at A I am drawing a perpendicular in such a way that this perpendicular is meeting this OB extension. Let's take that point as D. So I am going to extend OB up to D, and then I am drawing a perpendicular at A, and which is hitting the D, hitting the D. So this is the what we can say diagram. This diagram is going to help us to find this. Okay, so we will find the things very slowly. So first, here if you observe OBC, so this is one triangle, this triangle, and next above of it you can see a sector. Okay, one second. Yeah, and on the top of it we have something called OBA sector. This is a sector. Next, on top of it we have something, another triangle. This is ODA. So this is one more triangle, right? Okay. Now see, if you observe clearly, there is OBC, OCB is a right angle triangle. This is one triangle, and next OBA is a sector. Okay, so it's a clear differentiation or a clear understanding or clear view that OBC triangle is smaller than OAB sector, because OCB is a part of OAB. So definitely this is a smaller part. This part is very small. This is a part in the sector. Therefore, definitely OCB area is smaller than OBA area. Next, again, look at this ODA triangle. This ODA triangle is a part, sorry, OBA is a sector. This sector is a part of ODA triangle or OAD triangle. OAD right angle triangle. OAD is a bigger right angle triangle whose part is sector, and in sector we have one more triangle OCB, and that is a part of sector. So one thing is very clear. Okay, let's keep for your easier understanding. Let's keep the first triangle is the smaller triangle 1, and the sector one is 2, and the other one is a 3. So definitely the area of 1 is less than area of 2 is less than area of 3, or what we can say is area of OCB is less than, or area of OBA sector is less than area of ODA sector. So that is the point we can write it from this diagram. So what we can write here, we can write area of OCB, that is smaller than what? Sector. Area of sector OAB less than area of another triangle. What is that? OAD triangle. Right. So this is a point we can understand or we can perceive from this diagram. Area of OCB smaller than, less than area of OBA is less than area of OAD. Now look at this one. What is OCB? OCB is a right angle triangle. So how to find the area of a right angle triangle? So generally to find the area of a triangle we have a formula 1 by 2 into base into height. So I would like to take OC as a base. So 1 by 2 into OC into height is BC, because height is nothing but altitude. Altitude which is drawn from base to its opposite vertex, and this is the altitude which is drawing from base to its opposite vertex. So 1 by 2 into OC is less than OC into BC. Next, sector area. So this is the sector area. Now sector area, okay, the sector area formula is, okay, LR by 2. What is the area of a sector? LR by 2. So L into R by 2. I will explain in the end why this is LR by 2. If you want, I will explain now only. Next, less than area of OAD. What is this? It's again a right angle triangle. So 1 by 2 into, okay, base I would like to take OA, and OA, and what is the height of it? AD. 1 by 2 into OA into AD. So coming to this one, why this is LR by 2, we'll see for some time. See, you already know that a sector area formula. See, for example, let's see, this is a circle. This is a circle of radius r. What is the radius of it? R. Now, for example, what is the angle from here to here? What is this complete angle? It's a 360 degrees, right? So, if, let us assume, okay, see, let us assume this is one a fixed ray. Let's see, this is O and this is A. This is a fixed ray of radius r. Now there is another ray which is standing or which is landing on OA. Okay, that is one more ray. Okay, now what is the, for example, let's see, that is OB. Now what is the angle between OA and OB? Okay, they are coinciding and there is no angle. So therefore there is no area because there is no circle. Okay, so if the angle is 0 degrees, if the angle is 0 degrees, the area is 0. Okay, let's assume that it made one revolution. So that means it made one complete revolution. So if the OB rotates and makes one complete revolution, so then it will make one circle, and that is a complete circle. That is how many degrees it made? 360 degrees it made. So what is the area it is formed? The radius is r. What is the area it is formed? Okay, you know the formula, it is pi into r square. It makes the pi r square. What is the area of this circle? What is the area of this circle? That is pi r square. So for 360 degrees, it is making pi r square area. If the angle is 360 degrees, it makes pi r square. Now, for example, tell me for 1 degrees, how much area it occupies? Okay, that's just a unitary method. Okay, if you can understand 360 degrees as 360 into 1. Okay, now this is multiplying when you transfer to this side, and because the radius and the area, if the degree is increasing, okay, if the angle is increasing, the area is also increasing, so they are in a proportional form. So therefore we can assume normal way, this is proportional. 1 degree, 1 into 3, 1 into 360. So 360, if you transfer to this side, what will happen? It is pi r square by 360 degrees. This is for what? 1 degree. Okay, 1 degree, the area is pi r square by 360. What is the meaning of this one? The meaning is very simple. Okay, if the angle is 1 degree, what is the area of a circle? For let's assume this is a 1 degree. 1 degree. So in 1 degree, how much area it will occupy? Pi r square by 360. Okay, if the area is total pi r square, okay, out, if the area is total pi r square, if pi r square is making into 360 parts, one part will be 1 degree area. If the angle is 1 degree, then at that place it makes the one part, how much 1 degree will make the area, that part will be pi r square by 360. Okay, for 2 degrees, 1 degrees, it is 1 into pi r square by 360, we can say like that. Okay, next for 2 degrees, it is 2 into pi r square by 360. So I am trying to explain how sector area formula is theta by 360 into pi r square. So for 3 degrees, it is 3 into pi r square degrees. For example, if the angle is theta degrees, then it is theta into pi r square by 360. So this is the formula to find the sector area. So what is the formula? Theta into 3 pi r square by 360. This can also be written as theta by 360 into pi r square. Okay, this one thing you keep it in the mind. Okay, but here this theta is in angle, sorry, this theta is in degrees. Okay, this is the reason why we are writing 0 here. Actually exponent, I mean power as a 0, that is degrees, it represents degree. So what is the sector area formula? Theta by 360 into pi r square. Theta by 360 into pi r square. Now, so just keep this in your mind because it will help us. There are different ways to understand it. Sector area is equals to theta by 360 into pi r square. Next, the same way, one more thing we are going to find it. What is that? For example, see, let's assume now we are discussing about, uh, for example, let's take one circle once again. Okay, now this is radius. This is also radius. So these are radii of a circle. Now what do you call this space? What do you call this region? It's a sector region. What do you call this? Sector. In fact, it is a minor sector. Now how to find the area of this minor sector? Okay, we have a formula. That's fine. But I am not interested to find the area. Okay. See, if you see here, let's see, what do you call this one? Is it not R? And let us assume that length is something called L. That length is something called L. Now, for example, let's assume it made a complete rotation. If it makes a complete rotation, what is this L value? For example, this is L. Okay, it's going to become what? It's going to make a complete revolution. So what do you mean by complete revolution? For example, it started from here to here. What is the length? Is it not the circumference of a circle? So therefore, it is a circumference of a circle. That means if the angle is 360 degrees, then the length of the arc length, that is L, okay, if this is angle, then that is going to be 2 pi r. 2 pi r. Now for example, if what is the arc length if the angle is 1 degree? So it is 2 pi r by 360. Just now I explained the unitary method. 2 pi r by 360. For any angle, for theta, it is, because for 1 degree it is 1 into 2 pi r by 360, and for theta degrees it is theta into 2 pi r by 360 degrees. So theta by 360 into 2 pi r. This is the formula of the length of the arc at theta degrees. For example, if the angle is theta degrees, then for theta degrees, what is the arc length? Theta into, okay, theta by 360 into 2 pi r. Okay, now if you observe these two things, okay, you observe these two things. Okay, so this is the arc length formula. What is the arc length formula? Arc length is equals to, I'm sorry, Okay, arc length at theta is equals to theta by 360 into 2 pi r. You can find a little similarity in these two, but it is sector area and this is the arc length, L value. Okay, now what I would like to do is I wanted to express this sector area formula in terms of arc length. Okay, arc length means I would like to denote with as L. Now, so look at this one, theta by 360, you can see here. Okay, you can see pi r also. So, and only the 2 is not there. So, I would like to write theta by 360. Okay, and I have pi. Okay, this r square we can write as r into r. So, I have pi r also. So, what can I write about theta by 360 into pi r is equal to L by 2, right? L by 2 into r. So, that is LR by 2. So, this is LR by 2. You got the point? Once again, theta by 360 into pi r. Theta by 360 into pi r place. Okay, can I write it as, see theta by 360, 2 you remove it. Okay, 2 I am transferring here. So if I transfer 2 here, it will become L by 2. L by 2 and here r. So this place, theta by 360 into pi r place, I can write as L by 2. So LR by 2. So this is how the sector area formula have come. There are people who are confusing, therefore I would like to write that. So sector area formula also we derived it. See, the point is very clear that don't if possibility, I mean if you don't understand, I mean if you don't know it, then try to derive it. We have a possibility. Now, so that is how we got L into R by 2. Now come back to the theorem. I'm so sorry for lagging the discussion too long. Just to cover the basics, because if you don't have the strong basic foundation and no confidence in the basics, then it will doesn't lead to I mean you doesn't go the confidence, you doesn't go forward in confidence mode. So I just wanted to bring up that confidence into you, that you are comfortable or you are confident at every step. That is the idea, right? Come back to this one. Now 1 by 2, 1 by 2 we can cancel here. This is possible. See, it's very simple. What I wanted to say is, can I say 2 is less than 3? That's fine. Correct? 2 is less than 3. It is true. For example, if I multiply 1 by 2 at this side, 1 by 2 is this side. So it is going to become what? Okay, let's cancel this. You will get 1 here. You will get 1 by 23, right? You will get 3 by 2. Can I say 1 is still less than 3 by 2? Because you will get 1.5 something. So even you multiply or divide, cancel at both sides of any equations, it is true. So therefore, here 1 by 2, here 1 by 2, here 1 by 2. So or else you can understand one thing. You multiply with 2. If you multiply with 2, what is going to happen? This 2 and 2 gets cancelled, right? So if you multiply an equation with same number, it doesn't make any difference. For example, 2 is less than 3. Once again, just concentrate once again. Once again, 2 is less than 3. Now what I am going to do is, I am going to multiply this entire equation with 3 or something called 4. Here also I am multiplying 4. 4 2s are what? 8. 3 4s are what? 12. So 8 still maintains the relation. 8 is less than 12. So there is no chance of changing a sign. It still holds true even you multiply, but you must multiply with the same number. And one more thing, you must be multiplied with a positive number. Okay, whichever the number you are multiplying, that must be a positive number. If you multiply negative, then it will be a different case again. But until and unless you multiply with the positive number, the relationship holds true. The relation holds true. Okay, right. So why I am talking about this one, because here these two also gets cancelled. Or else if you multiply with 2, okay, this 2 and 2 gets cancelled. 2 and 2 gets cancelled. 2 and 2 gets cancelled. Now finally you are going to get OC into BC, L into R, OA into AD. Now here look at this OC and BC. Okay, forget about this one. But see, we already assumed this circle is a unit circle. What do you mean by unit circle? Whose radius is 1. So therefore, here this value is going to become what? R place. I can write it as what? R place. We can write it as what? 1. L into 1. L into 1. Next. Here what is OA? OA is a radius, so I can keep something as 1. Next AD we'll discuss about that later. So what is the final form? What is the form we are going to get? Let's see, OC into BC is less than L into 1. So we can simply write as L, but still I am writing as L into 1. OA value is 1, 1 into AD. So this is the value. We are going to get it finally. Next, what we can do here. Now see, if you look at this entire expression or in equation, you don't feel like you are traveling towards sin x by x, because there is nothing called sin x, nothing called x here. We are not using a radian still, we are not using a sin x still. So angle we are not using, sin x we are not using. So what we need to do is, from this expression, something you try to extract in such a way that which available or which happens or looks like sin x by x. So what I would like to do is, okay, any chance that I can make this OC by BC in terms of sine, or else look at this AD. AD is what for x. If you observe this big triangle, there you can see x, sin x is equals to, if I apply sin x, AD by OD you will get, okay, or else you will get other things also, right? Now let's see BC. What is BC? BC for x, respective x, BC is the opposite side. So I have a little chance to express this BC in terms of sin x. So I would like to go for it. Now I would like to apply sin x function for triangle OBC. OBC is a right angle triangle. Therefore we can apply the trigonometric ratio, and I am applying it. So sin x is equals to what? Sin x is equals to BC by, okay, opposite by hypotenuse. So hypotenuse is OB. But what is OB? OB is the radius of a circle. So therefore OB value is 1. So you can take this as 1. So therefore in place of BC by 1, BC by 1 means BC. So therefore in place of BC, I can simply place it as sin x. This is sin x into. Now look at OC. For x, what is OC? For x, what is OC? It's actually an adjacent side. And which trigonometric ratio will give the adjacent side, which is cos x. So therefore, I would like to apply cos x. See why I am doing it? Because I don't want this all to be dealt with the lengths. I wanted to express this entire length into the trigonometric form, because I have the form, or I need to prove, the thing which I need to prove is in the trigonometric. So trigonometric form. So therefore I would like to translate this into the trigonometric forms. So cos x. So cos x is equals to what? Cos x is equals to adjacent by hypotenuse. That means OC by OB. OC by OB. But once again, what do you mean by OB? It's a hypotenuse. It's not just a hypotenuse. Respective triangle, it is hypotenuse. But respective circle, it is a radius. And the radius of the circle is 1. So once again, OC by 1. OC by 1 means OC, which is nothing but cos x. So therefore, in place of OC, I can write as cos x. And slowly, we are just getting into the form of this one. But still, we didn't get it. Let's see that. Okay, next. What is this L? L is the length of arc, that is AB, which is, this is what we call it as length of the arc. Now we have another formula. Okay, I forgot to explain, because if that's actually too much discussion. L is equals to R into X. This is a formula. When actually in textbook it will give like L is equals to R theta C, because theta is not in angle. Sorry, theta is not in degrees. It is in radian. Whenever the angle is in radian, then how to find the length of the arc? How to find the length of the arc? If the angle is in radian, this is the formula. L is equals to R theta. Okay, if you want, I will try to explain what do you mean by this. So it's very simple. Actually, radian. See, if you look at a circle or the angles are expressed in different countries with the different names, with the different comfortability, or we can say different units. Okay, for example, we have SI system, FPS system, MKS system, CGS system. Okay, British system, American system, something like that. Okay, so same way the circle. Okay, so what I'm going to do is, so our next focus is why L is equals to r theta. Okay, here we are going to cover a lot of things. The video is a very long discussion, but still I hope it makes the little difference. So what are we going to prove? So we are going to prove why L is equals to R into, so instead of taking theta, okay, let's take theta only. Theta, but it is in radian. Right. See, for example, if you take a circle, okay, now what is this circle is divided into 360 parts, and each part is calling as degree. So this is the system of degree. So 360 degrees. I mean, the circle is divided into smaller parts. Okay, let's assume like this: 1, 2, 3, 4. But they made into what? 360 parts. Each part is called 1 degree. 1 degree. So therefore, entire circle is nothing but what? 360 degrees. The entire circle is divided into 360 smaller parts. Each part, I mean, the angle between the any two consecutive radii is 360 degrees. You can assume this one with the flag, the Ashoka Chakra. The Ashoka Chakra is having 22 spokes, right? Now the two consecutive spokes is, for example, if the Ashoka Chakra is divided into 360 parts, okay? Imagine there are 360 spokes are there. Now the angle between any two spokes is 300, any two spokes is 1 degree. So that is about this one 360 degrees. But okay, this is one people, I mean one country or one region people have used this system. That means they divided the entire circle into 360 parts. There are some people, okay, in other case it's actually British system. I forgot the name of it. Maybe it is a European system. They divided the circle into 100 parts. Okay, they just made it to 100 parts. See, it's my wish. I can make the circle into any number of parts. Okay, so they made into 100 parts. So same circle, but they divided into 100 parts. So and each part they are calling as grade. So 360 degrees is nothing but 100 grades only. Okay, they divided the circle into 360 parts, and these people, European people, divided into 100 parts, and each part is 1 grade. 1 grade means the angle between the two radii of a circle, consecutive two radii of a circle. Any two radii, not any two. The consecutive two radii is one part is nothing but 1 grade. So 100 grades. Next, again, it's been, there are some people who divided the circle into only two parts. They just made it into two parts. And this part, I mean the angle from here to here is, they said like this is pi c, that is means pi radians. They are expressing only two part, and that part they are representing as pi radians, pi c. So this is the reason why most of the time when you write pi, it's not actually degrees. If you convert into pi, it will become 180 degrees. So it's actually a radian system. This is the most standard system people not conveniently use it in a normal mathematics, but in the advanced mathematics, most of the time we'll use radians only, right? So that's a pi c. So that means, okay, from here to here the angle is pi c, and from here to here it's another pi c. Pi c and pi c. We should not say pi c, pi radians, pi radians. So half circle, they divide into two parts, and each part they are calling as, each part, I mean this one is pi c and pi c. So therefore it is 2 pi c, 2 pi. So 2 pi radians is nothing but 360 degrees only, because this is pi c, pi c. So it's covering the entire circle. So entire circle is nothing but 360 degrees. So 360 degrees and I'm so sorry, 360 degrees are pi grades and 2 pi radians. They are not different. They are just, I mean, just like a different languages we can say. Okay, right. 360 degrees pi grade, 100 grades, 2 pi radians. They are all same. Why are we discussing about it? So once again come back to this one. L is equals to R radian. That's about radian only. We need this discussion. Otherwise, you cannot be fully confident on this, right? So they divided, I mean 1 radian, okay, this is called 1 radian. Okay, so they said like this. For example, this is one circle. Okay, this is a radius, and this is also a radius. Let's imagine if the angle between the two radii is 1 radian, then the length of the arc is going to be 1. You got the point? Okay, for example, if the angle, see what do you mean by this? Sorry, that is equals to r. I'm so sorry, this is not 1. For example, this circle, this is a circle, and whose radius is something r. Okay, this is also going to be r. And if the angle between, okay, if I write this much small, you feel like it's not really. Okay, okay, now this is also r. For example, if the length of the arc is also r, then it's r. Actually, it makes the 1 radian. Now, see, for 1 radian, it is making 1 r. For 2 radians, it is making 2 r. Uh, Actually, so this is one thing. Now, I just wanted to make it one more point. Maybe you will understand better in that way. For example, this is one circle, right? This is one circle. And what is the angle? What is the, how many radians it is from here to here? 2 pi radians, right? 2 pi radians. So if the angle is 2 pi radians, see what I am going to do is I am going to find the relationship between the radians and length of the arc. Here the radius is r. Radius is r. Okay, right. Please hold on your attention for a few more minutes to get a clarity. So here 2 pi radians. If the angle is 2 pi radian, what is the length of the arc? Is it not 2 pi r? For 2 pi, for example, if the angle is 2 pi radian, what is the length of the arc? Is it not 2 pi r? Now, for 1 radian, what is the value? So, 2 pi r by 2 pi. Now, 2 pi and 2 pi gets cancelled. So, 1 radian is nothing but what? 1 radian is nothing but what? R. That means, if the angle is 1 radian, then length of the arc, this is actually length of the arc. The length of the arc will be r. Correct? The length of the arc is r. For example, if 2 radians, it will be what? 2r. For x radians, it will be what? X into r. But what is x into r? That is the length of the arc. So therefore, L is equals to x into r. What is x? X is an angle. X is an angle, but it is in radian. So therefore, L is equal to xr. Here, L is equal to, instead of x, now I am writing theta. It's actually in radian. Pi into, sorry, theta c into r. So that's how we got it, r into theta c. Okay, I'm calling it as theta c. I am not aware that it's really theta c. We should, is it appropriate to call theta c or not? Okay, so I hope you got the clarity. So L is equals to r theta. So it's again, once again we move out of the discussion, right? So L, now why are we discussing? L is equals to r theta, but here L is equals to r value into theta is how much? Theta is a radian, so that is x. L is equals to rx. So therefore, I can write L is equal to rx. One more thing also I can write, r value is radius, radius value is 1. So therefore, L place, what can I write? X is less than, okay, AD. Now what is AD? If you look at this ODA triangle, AD is the opposite to x. For x, AD is the opposite side. So now, for example, just imagine, let's make a small mistake and we'll learn the things from a mistake. So for example, I would like to take this as sin x. So sin x is equals to what? Opposite by AD by and hypotenuse, which is OD. Now AD value, okay, now look at this OD value. We cannot find the value of OD. Up to OB it is radius, but we don't know this extra length, BD value we do not know. And even I take, it's going to become complex. What I wanted to do is, I wanted to express this area as a single trigonometric ratio. So there is another way to take it. Okay, what I am going to do is, I, instead of taking sin x, I am trying with tan x. See, now you will understand the you will understand why we are why tan x is going to helpful. Tan x is, I mean, if I take sin x, I am getting this by this value I do not know, so I cannot write. And when I write also r plus, for example, if I write y, that y cannot be eliminated easily, because we want everything to express in sin x by x. But here we are getting cos x. Yes, cos x we can translate and make into a tan form, but you cannot convert this length into a, I mean, this only portion of a length into a trigonometric ratio. That's a too difficult thing, or it's too complex if I take this OD. So this is the reason why I would like to take this as a tan x. Now what is tan x? Tan x is equals to what? Opposite by adjacent. So therefore I would like to take tan x. So tan x is equals to what? AD by OA. AD by OA. OA is once again radius. So therefore your value is 1. So AD by 1 is AD. Therefore tan x is equals to AD. So I can simply write this AD as tan x. Just imagine if I try with the sin x, then it's going to be like this. Sin AD by, okay, AD is equals to, for example, AD by, for example, this length is r plus and a 1 plus y. We need to write 1 plus y. So that's too difficult thing. So I mean we cannot eliminate that y value. So this is the difficult part uh, in this for not taking a sin x. So that's, so tan x. So I'm just explaining. See why we cannot take sin x, why we cannot take cos x. Almost all the problems are associated with the same. So we can take like that. So I'm taking tan x. So now sin x, tan x. So this tan x also I would like to write it as sin x by cos x. Okay, because I want everything to get into the form of what? Sin x by x form. Now slowly we got the form sin x, but still we have cos x issue. So what I am going to do is I am going to divide this entire equation with okay, we want sin x by x. So but I don't think we'll get sin x by x. To get the sin x by x, okay, so I would like to do one thing. First I would like to write this as x by sin x, then I will flip the equation. So the entire equation I am going to divide with sin x. So if I divide with sin x, then nothing will change, because it's an equation. In equation all the terms we are dividing, so not a problem. So I am dividing with sin x. So sin x gets cancelled. Sin x by cancel. Now we got x by sin x, but still we don't want x by sin x, we want sin x by x. So that, to get it that, now cos x is less than x by sin x is less than, this is 1 by cos x. So that is the form we got it. Now, right. So we came to the end of the discussion here. Let us assume cos x, it is a function. Let's imagine this function name is f of x, and this function name is something called h of x. I told you in the starting sandwich theorem. So f of x limit. So I am going to find the limit for cos x. I am going to find the limit for 1 by cos x. If cos x limit and 1 by cos x limit, that means f of x limit, h of x limit is same, then I can say x by sin x is also going to be same. But before that we need to do one more flip. Okay, we need to rotate this equation. So if I rotate this equation 1 by cos x, whenever the equation is flipped, the less than will become greater than, and x by sin x will become what? Sin x by x. This is the form we are looking for. This one is less than, it's going to become cos x. So my explanation will be, we should start it here instead of there. So this is f of x. So what I am going to do, 1 by cos x is f of x, cos x is h of x. If the limit of 1 by cos x and limit of cos x is same, then we can say that limit is also same for sin x by x. So I would like to find the limit for 1 by cos x. So limit x tends to 0, because we need to find for x tends to 0. X tends to 0, 1 by cos x. So generally to find the limit, we'll try with the substitution method. If the substitution method doesn't help us, then we'll go for the rationalization or factorization or any other transformations will follow. But here, if I substitute x value 0, what are you going to get? 1 by cos 0. Cos 0 value is 1. So therefore, what is the limit of 1 by cos x? 1 by cos x limit is 1 by 1. So 1 by cos x plus, right, 0. So cos 0 is 1. Cos 0 is 1. Therefore, 1 by cos x is equals to 1. I mean, if x is tends to 0, then 1 by cos x will tends to 1. That is what the meaning of that. Now also find the h of x limit. Limit x tends to 0 cos x. So if I substitute x value 0, we will get what? Cos 0. Cos 0 value is 1. What do you mean by this? The limit of 1 by cos x is 1. The limit of cos x is also 1. That means these two limits are same. F of x limit, h of x limit is same. If f of x limit and h of x limit is same, okay, it may be greater than or equals to. I'm sorry. This is less than, right? Okay. Now you may write this one in the other direction. This way also you can write. Okay. For example, cos x. If you just flip the entire equation, 1 by cos x here, no, this is sin x by x, no. If you write the entire equation, still we can write cos x is less than sin x by x is less than, okay, 1 by cos x, but still you will get the same limit. 1 by cos x limit is also 1, cos x limit is also 1. So therefore f of x limit is 1, h of x limit is 1, therefore sin x by x limit is also 1. So therefore limit extends to 0, therefore limit extends to 0, sin x by x is equals to 1. So this is the clear proof of x tends to 0, sin x by x is equals to 1. I hope it is a very long discussion, but I hope it makes the sense or it makes worth in listening to this long discussion. Thank you. Even the student who do not belong to complex, I mean, do not have any idea about many things, they can understand and believe. Thank you so much. That's all for this. Thank you.